So, good afternoon to all the sir and sir. So, so today's afternoon technology in horticultural value chains, and the lecture will be delivered by Dr. R. Pandiswaram sir. So, I will tell a little bit about Dr. R. Pandiswaram sir. So, Dr. R. Pandiswaram sir is a senior scientist engineering at ICAR, Indian Agriculture Research Institute, New Delhi. He received his BTech in agricultural engineering and MTech in agricultural processing and food engineering from Tamil Nadu Agricultural University, Coimbatore. He completed his PhD from TNAU in 2015 and joined Indian Council of Agricultural Research in 2016 as a scientist at the ICR Central Plantation Crops Research Institute, Kasargod, Kerala. During his tenure at during his tenure at CPCRI 2016 to 2024, Dr. Pandiselvam significantly contributed to the design and development of several post-harvest machines and technologies, including a minimal processing machine for tender coconut, a continuous type coconut testa removing machine, a tender coconut cutting machine, preservation protocols for trimmed tender coconut, and biodegradable plate for tender coconut husk. He was also involved in the development and commercialization of value added coconut based food products such as Kalpa Crunch, frozen coconut delicacy, and matured coconut water based beverages benefiting over 80 entrepreneurs. He has trained more than 8,000 stakeholders through demonstrations and capacity building programs. Dr. Pandiselam has authored over 100 research and review articles in reputed journals, co-authored 9 books and 87 book chapters, and serves on editorial boards of several international journals. His achievements have been recognized with prestigious awards, including the National Academy of Agricultural Science Young Scientist Award 2020, NAAS Associate, then ISAE Distinguished Service Award 2020, and inclusion in the world's top 2% scientist list by Stanford University and Elsevier at 2023 and 2024. Recently, he was honored with the ICR Rashtriya Krishi Vigyan Puraskar 2025 Young Scientist Award for his outstanding contributions to agricultural engineering and Sir Pandisilam says start.
Yes. So, thank you for the nice introduction. So, today I would like to deliver a lecture on ozone technology in horticultural value chain. Okay. So, as mentioned in the introduction section, I am expertised in 2 areas. One is post-harvest processing of coconut, and another my area of research is ozone application in post-harvest technology. So these lectures, I am explaining about what is ozone and why we have to use ozone for post-harvest treatment of horticultural crops, and what is the advantage and limitations of ozone technology, and what are the major application of ozone in horticultural value chain and food grains. Okay. So mainly in case of fruits and vegetable, we know that it is spoiled due to microbial activity, enzymatic activity, due to the fungus growth, or after COVID, now people are also worrying about this virus control. Okay, so ozone is the technology. It has multi-application. Okay, so there are many research papers already. It was conducted in India and worldwide. It was proved that ozone is very effective for microbial control and for fungus control, and to control the ethylene in order to delay the ripening, And even nowadays, the cold storage rooms, they are passing this ozone gas in order to control this ethylene. So apart from this one, nowadays there are emerging issue is pesticide residues on fruits and vegetable surface. So ozone is the technology. It was proved that it is very effective against to removal of this pesticide residue from fruits and vegetable surface. So I am also slightly highlighting about ozone application for grain preservation, especially stored product insect control and the starch modification by using ozone, and as well as aflatoxin control. So ozone, generally before applying any technology to the food product, we have to get a approval. Okay? So ozone was recognized as safe and it got GRAS, generally recognized as safe status in 1997. But this technology entered in India in around 2019 to 20. So even now, there are many research work that they are going on to understand the effectiveness of ozone against this microbial control and to increase the shelf life of fruits and vegetables. So ozone we can generate by three methods, but the most commonly used method is corona discharge method. Okay. So in corona discharge method, we are passing the oxygen gas. So in the corona discharge method, if you observe, it has two electrodes. So if you pass the oxygen in between the electrode and we are supplying the high voltage, so the oxygen molecule will split and it will made it into singlet oxygen. That singlet oxygen will join with the O2 molecule and finally it will form ozone. Okay. So corona discharge method is the best method for production of ozone as compared to other two methods. The advantages of corona discharge method is the output of ozone or the concentration of ozone is very high as compared to UV light method and the electrolysis method. Okay. And even there is one more method for producing ozone is UV light method. This method is same, for example, if you know that we have ozone layer in our stratosphere. Okay. So how ozone is formed in the stratosphere? The science is the oxygen was exposed into UV rays, then the oxygen molecule was splitted due to the exposure of this UV rays, and the splitted oxygen molecule is formed a ozone. That's why the ozone is present in our stratosphere. Okay. So the same science was applied to produce the ozone at industrial scale level, and it is called as UV light based ozone generation. Okay. So when the oxygen is passed in the UV light, due to this UV light exposure, the oxygen will split again into singlet oxygen and it will form ozone. Okay. But as compared to UV light method, the corona discharge method is most effective. And even now, all the processing industries and the wastewater treatment industries, they are using corona discharge method to generate the ozone. So why we need ozone technology? What is the advantage in that? The main advantage is ozone is a non-thermal technology and it will not form any residue above the fruits and vegetable surface. Even if you are treating any food product with ozone, it will not form any residue on the surface of fruits or vegetable or any food product. Okay. And it can be able to generate on site. So whenever we required, we can able to generate it. And it is a most powerful oxidant. Even it is most powerful oxidant than chlorine. So if you observe, we mostly chlorine. So chlorinated water, it is used for fruits and vegetable washing purpose. But the problem with chlorinated water is, after washing with chlorinated water, the chlorine residue, it will be formed on the surface of fruits and vegetables. So mainly the fruits and vegetables subjected to chlorinated water in order to remove the dust and in order to remove the microbes. So the same purpose, if you use ozone, ozone is 1.5 times more powerful than chlorine. And as well as ozone, we can use it in gaseous form and liquid form. So even we can able to eliminate wastewater treatment generation when we are treating with fruits and vegetables. Okay, so there are two forms of ozone application that I will discuss in later. So this slide is also highlighting about ozone benefit. So as I mentioned, ozone is increasing the shelf life of fruits and vegetables because we can use this ozone technology in order to kill the microorganism, fungus, and even we can kill the virus. And also we can able to remove the pesticide residue that present on the surface of fruits and vegetables. And as I mentioned, we can use ozone for ethylene removal, and in order to delay the ripening, we can use the ozone technology. And nowadays, this ozone was widely useful in cold storage room. So the cold storage room, the main advantages is it is for purification of that indoor, as well as it will eliminate this ethylene, and in order to control the fungus and microorganism in the cold storage room. So this video is visible.
Yes, sir, visible.
Okay. So these videos, initially ozone is useful for wastewater treatment. Okay. So this video is highlighting that how ozone was used for wastewater treatment. You see this video, now this oxygen molecule was splitted and it is forming ozone molecule, and it is forming O3 molecule. So this O3 or ozone molecule is interacting with the hazardous compound that is present with the wastewater, and it is destroying or eliminating this hazardous compound in the wastewater. Then after this ozonated water treatment, again this wastewater will be further subjected to activated carbon in order to eliminate the remaining residues and as well as remaining ozone. So the first application of this ozone technology is wastewater treatment. So ozone, even nowadays you might be seeing that swimming pool for purification of that swimming pool water. Now they are using this ozone technology. And it is not a new adaptation. Even 30 years back, the ozone was used for wastewater treatment. But now it is emerging for the application of this post-harvest treatment of fruits and vegetables. So if we want to use this ozone technology to treat the fruits and vegetables, we need these 5 equipment. Okay. So to generate ozone, we need oxygen. Okay. Yes, of course, we can use atmospheric air, but atmospheric air, mainly it has nitrogen. Okay. So if you use atmospheric air, the output of ozone concentration is very less. Okay. So instead of using atmospheric air, if we can use pure oxygen, the output of ozone concentration is more, or the yield of ozone is more. So we need oxygen concentrator or oxygen cylinder to generate this ozone, and corona discharge method based ozone generator. So we need ozone generator. So we need oxygen cylinder and ozone generator. So then from the ozone generator, whatever ozone it was produced, that ozone we can useful for post-harvest treatment of fruits and vegetables. Then for optimization studies, for optimization of this, because if you apply more ozone, it may affect the biochemical quality of fruits and vegetables. So we have to optimize the ozone concentration for each fruits and vegetables. Okay. So for research purpose, definitely we need ozone analyzer or ozone monitor to understand how much concentration is present inside the treatment chamber. So after analyzing the ozone concentration, or suppose if you produce the excess ozone, it should not directly release it to the atmosphere, because ozone also is toxic to human being. So before releasing the ozone, excess ozone to the atmosphere, we have to destroy. So there are some equipments are available, that is ozone destructor. Okay. So ozone generally highly unstable at higher temperature. So this ozone generator is nothing but inside there is a heating coil. So you can set more temperature. So if you pass the ozone at higher temperature, it will be easily degraded into the oxygen. Okay. So for our research purpose, we need these 5 equipment. One is oxygen cylinder or oxygen concentrator, ozone generator, then treatment chamber, then ozone monitor, and ozone destructor. And here the another main concern is ozone is toxic to human being. Okay, so the treatment chamber should be airtight. It should be hermetically sealed. And the second condition is ozone is a highly oxidation nature. Okay, so if you use any rubber kind of material or any plastic material, the ozone will cause highly corrosive in nature. Okay, so for ozone-based treatment, the treatment chamber should be made out of stainless steel. Okay, it should not be made out of rubber or PVC. So this is the industrial setup of this ozone treatment. Okay, here if you observe that here the ozone we are passing at a particular pressure. Okay, that's why many of the places in the picture they are putting the pressure gauge. Okay. And as I mentioned, the ozone contact surface, it should be made out of stainless steel SS304 or SS316. So this is a research conducted in Western Australia. So this research conducted for mango to increase the shelf life. Okay. So here they are not disclosed the concentration, but here what they are highlighted is to treat the mango with ozonated water for 10 minutes. It extends the shelf life for 2 weeks. So that is a study result they found it, and even it was published in many Indian newspapers. And this is a study conducted by our student from Tavanur. So the objective of the study is to increase the shelf life of tomato by using this ozone technology. So here we are not only checked the ozone concentration and exposure time. Here we have designed the ozone chamber. So the first objective is to design the ozone chamber for tomato. Second is to optimize the concentration, and third is to conduct the shelf life of ozone treated tomato. And this is the methodology we followed. We purchased the tomato, local tomato, and then after that it's subjected to cleaning, grading, and washing. Then it was further subjected to air drying at room temperature. Then before treatment, we have analyzed the biochemical quality. Then it was subjected to ozone treatment. Then after a treatment, again we have analyzed the biochemical quality. Then along with the biochemical quality, we have also evaluated the sensory quality. Then further it was subjected to packaging, storage for shelf life estimation. So in our study, we have varied the ozone concentration, we have varied the exposure time. The one more variable we fixed is ozone temperature. Because many of the studies, they highlighted that ozone is stable at low temperature. So as I mentioned, the ozone destructor is working on the principles of if you apply the ozone at higher temperature, it will be easily degrade or it will be easily converted into oxygen. Okay. If it is easily converted into oxygen, it is not effective to control your microbes or fungus. Okay. So we need as such ozone form. So in order to increase the stability of the ozone, here we have conducted the experiment at 10 degree, 20 degree centigrade and 30 degree centigrade. And before and after treatment, we have analyzed the biochemical and sensory quality of tomato. And this is a designed treatment chamber. Here it was the treatment chamber is connected with this refrigeration chamber. So here inside the treatment chamber, we can able to maintain 10 to 30 degrees centigrade. So from the study, we optimized that 30 percentage ozone concentration. That means 0.6 gram per hour. So 30 percentage of ozone concentration at 10-degree temperature at the exposure time of 11.7 minutes will extend the shelf life of tomato up to 21 days. As I mentioned, the ozone is very effective at low temperature. At 10-degree temperature, the stability or half-life of ozone is high. So as I mentioned, at the optimized condition, we have conducted the storage studies at a different packaging material. The storage studies also conducted at the atmospheric temperature as well as refrigerated temperature. So the conclusion of our study is ozone is very effective to control this microorganism. And in fact, it extends the shelf life of tomato up to 21 days. This study result even we have published in a research paper in the journal Ozone Science and Engineering. So if you want more data, you can refer our article. And these videos, I am just want to show how ozone is useful in industry, in fruits and vegetable washing, how they are using this ozone. So this video highlighted that how ozone was useful in fruits and vegetable washing. And there are one more video. So tomato initially washed with normal water, then it will be subjected to ozonated water. So this company, Chemtronics, is located in Mumbai. They are supplying this ozone-based fruits and vegetable washer. So while performing this ozone treatment, we have to consider this extrinsic and as well as intrinsic parameters. So mainly, as I mentioned, ozone we can apply in gaseous form and as well as aqueous form. So for treating a dried or dehydrated product, we have to go for gaseous ozone. Or in order to treat the grains or cereals, we can go for gaseous ozone. And for fruits and vegetable purpose, we can go for aqueous ozone. Okay? So based on the nature of the product and finally end use, we can select this physical state of ozone, either gaseous phase or aqueous phase. Second one is concentration. As I mentioned, if you go higher concentration, yes, definitely we could able to achieve more microbial log reduction. But the problem is, if when we go for higher concentration, it have negative effect on these biochemical properties of fruits and vegetables. Okay. And third thing is exposure time. So exposure time is depends on concentration of ozone. If you treat your commodities at a higher concentration, we can go for lower exposure time. And if you can go for low concentration, then we have to go for higher exposure time. The flow rate. So most of the research study, they highlighted that the ozone flow rate of 1.5 to 2 liter per minute is more effective for this microbial control. Okay. And temperature and RH. So in our research studies also, we found that at lower temperature, the ozone stability is very high. So the effectiveness also very high. And in terms of intrinsic parameters, for example, you want to treat a ozone for microbial control in any fruit juice. If the fruit juice have acidic in nature, then the ozone effectiveness is very high. Because ozone is highly unstable in alkaline nature. Okay. So if the ozone is very effective for acidic based fruit juices, and the second thing is organic matter. So if you are treating any fruit juice with ozone, it is always suggested that you have to use filtration before ozone treatment. Because if the juice have more organic matter, then the organic matter will consume the ozone. So it is not available for microbial reduction. So we have to do filtration or we have to minimize this organic matter before a ozone treatment. Then the third most important thing is moisture content. If moisture content is very high, the moisture content of the product is very high, it should be exposed with low concentration as well as low exposure time. Because if the moisture content of the product is very high, again there is a chances of reaction with ozone and food product. So yes, the ozone is very suitable for low moisture food product. And yes, of course, we can useful for high moisture food product, but we have to use for low concentration and low exposure time. So this is the mode of action explaining how ozone is effective to control these microorganisms. This reaction is called oxidative burst. When the bacterial cell is exposed to this ozone molecule, due to this oxidation potential of ozone, it is creating the hole on the surface of bacterial cell. So finally, the cell wall of this bacteria will be collapsed. Then the internal structure will be collapsed. That is called cell lysis. So due to this cell structural collapse, finally it leads to death of this bacterial cell. So we have reviewed or we have written a review paper on how this ozone is effective for different fruits and vegetables. So we understand that ozone is very effective for bacterial inactivation. And even if you apply less than 10 minutes exposure time, we can able to achieve 80 to 90% reduction of microorganism. And even at lower concentration, we can go maximum 10 ppm is sufficient to reach 5 log reduction in many of the fruits and vegetables. But as based on the research studies, we observed that ozone is more effective for gram-negative bacteria as compared to gram-positive bacteria. Because it was reported that gram-positive bacteria have peptidoglycan layer. So due to this peptidoglycan layer, the gram-positive bacteria is resistant, somewhat resistant to ozone as compared to gram-negative bacteria. So these videos are highlighting about how ozone is effective for leafy vegetables. If you observe this video, the left side sample is ozone treated leafy vegetable, lettuce. The right side sample is treated with RO water. See, within 4 hours, the RO water treated lettuce is started shrinkage. But ozonated water treated lettuce is more fresh even after 10 hours. So as we know, so the preservation of leafy vegetables are very difficult. But this video, they demonstrated that even 0.2 ppm of ozone is extending the shelf life of this leafy vegetable, or it is keeping the leafy vegetable more fresh even after 10 hours. So as compared to RO washed leafy vegetables, it started shrinkage even within 4 to 5 hours. But ozonated water is extending the freshness of leafy vegetables more than 10 hours.
दुर्घटना से सुरक्षा भली, खेतों से मार्केट तक और मार्केट से आपके घरों तक सब्जियां और फलों को न जाने कितने केमिकल्स और बैक्टीरिया का सामना करना पड़ता है और इन्हें सिर्फ बेकिंग पाउडर या नमक वाले पानी से धोना काफी नहीं होता। आपकी इसी जरूरत को पूरा करने के लिए सेलो लेकर आया है आधुनिक ओजोन टेक्नोलॉजी वाला वेजिटेबल एंड फ्रूट क्लीनर, जो न कि सिर्फ फलों और सब्जियों को जानलेवा बैक्टीरिया वायरस से बचाता है, बल्कि उन पर लगे केमिकल्स, पेस्टिसाइड्स और आर्टिफिशियल प्रिजर्वेटिव्स का भी खात्मा करता है और उन्हें लंबे समय तक फ्रेश रखता है। इसमें फल और सब्जियों के अलावा आप फिश, मीट, दाल और चावल में छुपे हुए बैक्टीरिया एंड पेस्टिसाइड्स को भी आसानी से साफ कर सकते हैं। यहाँ तक कि आपके शिशु की दूध की बॉटल्स और किचन की छोटी छोटी रोजमर्रा की चीजों को भी स्टेरिलाइज कर सकते हैं। जितनी अट्रैक्टिव सेलो क्लीनर की डिजाइन है, उतना ही आसान है उसे इस्तेमाल करना। इसके पावर पिन को इलेक्ट्रिक सॉकेट में कनेक्ट कीजिए, फिर कंटेनर में मार्केट से लाए हुए फलों और सब्जियों को रखिए। ध्यान रखिए कि ड्रेनेज पाइप अपनी जगह पर लगा हो, फिर उसमें पानी डालिए और लीड लगाकर उसे बंद करें। ऑन का बटन दबाइए और आपकी जरूरत के अनुसार प्री सेट फंक्शन टाइमर चूज करें और फिर से ऑन बटन प्रेस कीजिए। फिर सेलो फ्रूट एंड वेजिटेबल क्लीनर की शक्तिशाली ओजोन टेक्नोलॉजी का कमाल देखिए। देखते ही देखते ये सारे फलों और सब्जियों को क्लीन, फ्रेश और केमिकल फ्री बना देगा। टाइमर खत्म होते ही आप कंटेनर का गंदा पानी ड्रेनेज पाइप के द्वारा बाहर निकालें और अपने फलों और सब्जियों को साफ पानी से धोकर इस्तेमाल करें। सेलो फ्रूट एंड वेजिटेबल क्लीनर को साफ करना भी बड़ा ही आसान है। इस्तेमाल करने पर आपको बस साफ पानी से कंटेनर धोकर पाइप से उस पानी को ड्रेन करना है। ये सिर्फ इजी टू क्लीन नहीं, बल्कि मेंटेनेंस फ्री और एनर्जी एफिशिएंट भी है और इसे आप बिना किसी तकलीफ के सालों तक इस्तेमाल कर सकते हैं। मार्केट में आपको कई वेजिटेबल एंड फ्रूट प्यूरिफायर मिलेंगे, लेकिन सेलो आपकी सुरक्षा को समझता है और इसीलिए हमारे प्रोडक्ट को उसी तरह से डिजाइन किया है। 10 लीटर के स्पेस के साथ आपके फल और सब्जियों को एक साथ ज्यादा मात्रा में प्यूरिफाई कर सकता है। इसे और भी खास बनाता है इसका ये बंद आकार, क्योंकि कहा जाता है कि ओजोन को ज्यादा मात्रा में इनहेल करना हानिकारक हो सकता है। सेलो फ्रूट्स एंड वेजिटेबल क्लीनर का 400 मिलीग्राम पर आवर वाला इनबिल्ट ओजोन आउटपुट बिल्कुल सेंटर में प्लेस्ड है, जिसकी वजह से ये बाकी पाइप गैस प्रोडक्ट से ज्यादा बेहतर और असरदार है। इस पानी में डाले हुए इंक जैसे केमिकल को ही देखिए, कितनी आसानी से ये इम्प्योरिटीज को खत्म कर देता है। ओजोन डिसइंफेक्टेंट टेक्नोलॉजी पूरी दुनिया में बड़ी फूड एंड बेवरेजेस कंपनीज में यूज की जाती है। सेलो इस टेक्नोलॉजी को आपके घर में उपलब्ध कराना चाहता है ताकि हर परिवार स्वस्थ, तंदुरुस्त और सुरक्षित रहे। तो अब इंतजार किस बात का है? आज ही किफायती दाम में सेलो वेजिटेबल एंड फ्रूट क्लीनर को अपने परिवार।
So these videos are highlighted that, in fact, after COVID, there are many industries in India. They fabricated this household ozone disinfection chamber because ozone was effective even against virus. So after COVID-19, there are many industries, even including cello, there are Faraday ozone or OZT air. There are many companies in India. Now, even it is available now in online. So it was proved that ozone is effective against virus, bacteria, and fungus. And if you observe this video, they are not only using for fruits and vegetables, even it can be also useful for treating this grain or washing your cereals and other things. So next couple of slides, I am explaining about how ozone is effective for this pesticide degradation in fruits and vegetables. So this is a survey conducted at India, and it is highlighting that most of the fruits and vegetables available in the market that have more pesticide residue on the surface. Even for example, if you take brinjal, it have 860% above the legal limit of pesticide residue. Similar way, the other fruits and vegetables also have more pesticide residue. Not only fruits and vegetables, even right side picture indicating that most of the soft drinks, it has this pesticide residue because our water was contaminated with pesticide residue as well as heavy metals and now even microplastics. And not only fruits or vegetables. If you see the survey, the spices, so they have taken 157 samples from the market. They found that 131 sample have more pesticide residue. Out of 157, 131 sample have more pesticide residue. Because in case of spices, after harvesting, it will be subjected to drying. We are not washing. After harvesting, it will be go for drying, then it will be converted into powder form. That's why most of the fruits and most of the spices also it have pesticide residues. And we analyzed this effect of ozone technology on pesticide residue reduction. We understand that ozone is effective to reduce the level of pesticide from 60 to 90%. And even both gaseous as well as aqueous ozone, both are very effective. But here, if you observe, we need to apply more concentration and more exposure time as compared to the microbial inactivation. As I mentioned, for microbial inactivation, we can apply maximum 10 minutes for 10 ppm of concentration. But here, for pesticide reduction purpose, we have to go for higher ozone concentration and more exposure time in order to achieve more percentage of reduction of pesticide residue. So the another doubt is whether the ozone is effective only for the surface level pesticide residue or that internal pesticide residue. So ozone does not have any penetration properties. Ozone will be reactive on the surface. So ozone is very effective only on to remove or to eliminate or to reduce the surface pesticide residues. So ozone, even last 2 to 3 years, nowadays ozone, they are exploring the application on starch modification. So we might be knowing that the starch, now the commercially it is useful for different industry, food processing industry. It will be useful for packaging industry. It will be useful for making jellies, candies, thickener, emulsifying agent. But the problem with native starch. So the starch extracted from any cereals or from any potatoes or tuber crops, it have low solubility, it have low thermal stability, it have low pasting profile, it have low clarity. Because of this issue, now industry they are using chemicals to modify the native starch. Okay? So ozone is one of the alternative to the chemicals for starch modification. So this is a setup for starch modification. For starch modification purpose, we need only aqueous ozone. So the ozone bubbles, it was released in the water. Then the starch, it will be subjected to aqueous ozone. Then after a ozone treatment, again, it will have to be subjected to drying, milling, and storage. Okay. So the ozone is replacing the chemicals in case of starch modification. Okay. So this is a chemical reaction. During this oxidation or ozone-based reaction, there is a formation of carboxyl compound. So due to the formation of carboxyl and carbonyl compound, it having these good properties to the starch. Mainly it is increasing this pasting profile and it is increasing the clarity. Okay. So this research study is conducted in Brazil and they have treated with starch with ozone at a different duration. So this is if you look the color, 0th minute, 15 minutes treated ozone and 30 minutes ozone treated starch. This is a 0th minute, that means there is a control. It have low pasting profile and the color, if you closely observe the color, it will be not that bright white in color. Just you observe the color here. After 15 minutes of ozone treatment, the color profile got improved. The whiteness index values is improved. The pasting profile is improved. This is the 30 minutes ozone treated starch. So they have more pasting profile as compared to 0th and 15 minutes ozone treated starch. So for starch modification, we have to treat a starch for 60 minutes. And on average, we have to treat it for 60 minutes. And we have to apply for more ozone concentration. It is not like a pesticide residue or microbial reduction. Okay. So after ozone treatment, as I mentioned, it is increasing the swelling power of the starch. It is increasing the retardation potential and it is increasing the pasting profile or rheological property. It is increasing the viscosity and it is increasing the color. Yes, we have conducted the research on application of ozone to control the stored product insect in cereals. Okay. So as we are aware, our cereals are getting affected due to these 3 major insects. So currently, phosphine are used. Phosphine they are using to control this stored product insect. So here, ozone is the alternative to phosphine. But the problem is India, mainly most of the storage structure they are using for back type of storage structure, or we are having the storage gowns. So for application of ozone for back type storage structure is very difficult. If you go for silos, yes, of course, ozone is one of the potential alternative to phosphine. So we have to understand that ozone is effective to control all kind of stored product insect. And this is a research work was conducted by our team. So we have treated the cereals with more higher ozone concentration, 1000 ppm. As I mentioned, cereals are having low moisture. It has a tolerance to higher ozone exposure. But if you closely observe the structure of the grains after ozone treatment, if you are going above 1000 ppm of ozone concentration, due to this oxidation potential, even it started framing the cracks on the surface of the grains. So that much oxidation potential the ozone it has. That's why it is even affecting the biochemical properties of the grains as well as fruits and vegetables. Okay. That's why we need to optimize the ozone concentration and the exposure time for each and every food product. So the next application is highlighting that how ozone is effective for aflatoxin. As per WHO report, 25% of the world grains are affected due to this aflatoxin. So this is the experimental setup for aflatoxin, and here, as I mentioned, we have to use ozone for silo kind of storage structure, not for bags. So for aflatoxin reduction, we need higher ozone concentration and higher exposure time. And it was proved that from 70 to 97% of reduction in aflatoxin. So after COVID-19, even there is a studies on effect of ozone on virus. So it was reported that ozone is very effective against virus. Even at low concentration, less than 1 milligram per liter, at a short contact time of less than 1 minute, is able to kill 99% of the virus. So before introducing any technology to the industry, so we have to know the cost economics. So we have analyzed the cost involved for ozone treatment. So myself and professor from USA, Dr. John Van Leeuwen, so we combined together, we have analyzed this cost economic study. And we have considered by different variables, fixed cost, variable cost, and all other factors. We calculated that to treat fruits and vegetables or meat product, we have to spend 0.86 paise per kg of fruits or vegetable or meat product. So this is a safety consideration. As per OSHA, a human being should not be exposed if the ozone concentration is more than 0.1 ppm. Okay. So if you are doing the research work, there are ozone detectors are available. So we have to fix the ozone detector inside the research lab in order to identify the ozone leakage. And we have to confirm that the environment should not have more than 0.1 ppm of ozone. So I have mainly working on ozone for last 10 years, and I have published more than 25 papers on ozone technology. And for your information, every year, 16th September, we will celebrate as a ozone day. Okay. With this, I am thanking for all the participants and the organizer for giving this opportunity.
Okay, sir. Thank you very much. Now the session is open for question answers. If anyone having questions, so please write your question in the chat box or turn on your mic. Anyone from the participant? Yes. Sir, one question in the chat box, sir. Ozone technology as disinfectant in mushroom production?
We're asking about to increase the shelf life of mushroom or production of mushroom.
Arjun, production.
Generally, production in the sense, yes, we can use ozone, but we have to know the purpose, whether you want for microbial reduction. Generally, we have extensively studied for post-harvest treatment. After harvesting a fruits or vegetable, how to increase the shelf life by applying this ozone.
Okay, sir. Any other questions? Okay, sir. I think no more questions. So we should conclude this session. Okay, sir.
Yes, okay, Anush.
Okay. Wonderful presentation, and the presentation are very good, sir. I love it. Thank you very much, sir. And also thank you all the participants, and also thank you our course director, Dr. Raman Silva Kumar. Thank you. Thank you, sir.
Thank you so much.